And we have engine start. And liftoff. From a tropical rainforest to the edge of time itself, James Webb begins a voyage.
It's taken 30 years to develop, cost more than $10 billion, and has involved thousands of scientists. This is the James Webb Space Telescope. It's the successor to Hubble, which has given us amazing images of space, but it's 100 times more powerful.
Hubble has completely revolutionized our understanding of the universe over the last 30 years, but there's a lot of ways that we've sort of pushed it to its limits. And this telescope is going to be the largest, most complex, and most powerful telescope that we've ever sent to space.
Gazing up into the heavens can help us to answer some of the biggest questions, like where we come from and how did we get here. This space telescope will help us to look further back in time than ever before, to 13.5 billion years ago, revealing the light from the very first stars to shine. We'll be able to see the earliest galaxy formation and whether they spiral into space like our own Milky Way. And other planetary systems will also come into view, allowing us to discover whether life could exist on other worlds.
Scientists will be able to study every phase of cosmic history.
We think that the first stars might actually be really huge, and they would be burning really hot and really brightly and would die very quickly, possibly with a huge explosion. But we haven't seen these yet, and we really hope that this is something that we're going to find with the Webb telescope.
The telescope is heading 1 million miles away from the Earth to give us our deepest ever view of the cosmos. But how will it work?
This space telescope is a feat of engineering. At its heart is a 6.5 metre wide mirror made up of 18 hexagonal segments, each coated in a layer of gold. Its size means it can detect the incredibly faint light coming from the most distant stars. It also has a huge sun shield about the size of a tennis court. It's made up of 5 layers, each as thin as a human hair. And this protects the telescope from the heat and light of the sun.
So the light from the telescope comes in down at the bottom here. You can see a red cover covering the entrance aperture.
On board, the instrument that will be key to these discoveries was built in the UK. It's called MIRI, and this is an exact engineering replica.
Webb will be able to do some wonderful discovery science that's simply not been possible before. We'll be able to see the first light galaxies, the first objects and stars that were glowing after the Big Bang. And to do that sort of science, we need MIRI. We need the data that only this instrument will be able to provide.
To get into space, the telescope's so big, it's been folded up to fit inside the rocket, like origami. The most challenging part is getting it to unfurl. It's been practiced here on Earth, and that's hard enough. There are 300 points where it could go wrong. But if anything fails in space, the telescope is too far away to be fixed.
We know there are many ways that it could fail. So that means rehearse and rehearse and rehearse. We've unfolded it and folded up many times. We've examined it carefully every time. We say, well, that's not quite right. We better fix that. And it's extraordinarily challenging.
It's high-stakes science, but scientists say the risk is worth it because the rewards could be huge.
What excites me is making discoveries, things we haven't thought about. And there's a whole history of astronomy that shows how when we've looked at the new universe in a new way, we discover things we hadn't thought about. And there's something really exciting about doing that.
This is the most ambitious astronomy mission ever attempted, revealing parts of the universe we've never seen before and answering some of our biggest scientific questions.